Every young graduate coming out of school today, one of their first questions are, what's your sustainability objectives? Do you drive EVs in your company? How can I get involved in this? So even from a recruitment standpoint, it's being pushed on companies that if you want good young talent, you have to be a leader in this particular space.
Hi everyone, welcome to the Climate Confident Podcast. My name is Tom Raftery, and with me on the show today, I have my special guest, Stuart. Stuart, welcome to the podcast. Would you like to introduce yourself?
Yeah, good morning, Tom. Good morning, listeners. My name is Stuart Thompson. I lead the Electrification Service Division for ABB. I'm very happy to be here today to talk about the climate change and offerings and that we can help to support the industry.
Okay, and for people, Stuart, who might be unaware, who are ABB?
So ABB is a Swiss multinational. We have been in the electrical engineering business now for more than 140 years. We're headquartered in Zurich in Switzerland. We have roots also out of Sweden. And for that 140 years, we've been looking after infrastructure from the power source of generation all the way down to the socket. We're globally based. We have nearly 110,000 employees, and we're probably one of the leaders in electrical engineering in the world today.
Okay, so typical customers are large industrial companies or mid-size or small? I'm guessing more on the larger side.
In general, I think on the industrial side, for sure, large customers are like utilities. So many of the large utilities around the world, the OEMs that make the wind turbines, the components that go into that, even down to commercial buildings. About 20% of ABB's electrification business goes into buildings, and then all the way down to the average consumer in your home. If you've got some type of lighting control system or circuit protection, in every home in the world has something like this, and you'll find ABB there. So through electrical distribution, electrical contractors, those businesses are generally using an ABB type product.
I've seen your stuff as well on EV charging stations. I have an EV, I'm on my fourth EV now, and I've seen a couple of ABB chargers when I've gone to charge my car in public chargers.
Absolutely. I think on a global basis, we've rolled out more than 1 million chargers globally, whether that's from AC installations in your domestic house, 7.4 kilowatt up to 22 kilowatt three-phase, all the way up to 500 kilowatt high-speed DC chargers. So 20 million chargers have been rolled out worldwide. Over 1 million of those are ABB. And it's definitely a growing area for the ABB operations.
And when it comes to the industrial players, Stuart, what are the biggest challenges they're facing today when it comes to decarbonisation, seeing as this is the Climate Confident podcast?
Yeah, look, I think many industrial players don't really know where to go or how to move forward on their net zero strategies today. Many know that they need to get there. Many know that they want to get there, but finding that economic model to go forward is extremely challenging for them. There's really three sort of main criteria for the big industrial players. The first one is around that basic energy security. We saw with the start of the Ukraine war, the Nord Stream gas pipeline shut down within Europe. We saw facilities going back to the basics of ensuring they have stable grid supply with increasing energy demands around the world. There's more and more pressure on the grid. So I'd say that the highest level of operation is around that resilience and making sure they have energy security in their operation. The second area is around affordability and keeping their costs down. But then there's this desire and push, both politically as well as within industrial economic powerhouses and companies, to drive towards net zero. So sometimes these three things can conflict, but there's always opportunities on how to align them and drive better performance. So companies are considering how to extend the life of their electrical assets in their sites in order to reduce potential carbon footprint by capital expenditure. Or the other thing that they're looking at doing is how do I move to a greener power supply and how do I drive energy security doing that, and doing that in a cost-effective manner with a good return on investment going forward. So many of them are sort of at this trilemma, trying to figure out how to manage these three aspects of their business. Ultimately, they want to be greener. They want to reduce their carbon footprint, but most of them are trying to figure out that challenge and how to go forward and achieve that.
Mm. Do they really want to reduce their carbon footprint, or do they just want to keep their costs down?
Well, it depends on the company. I think there's a lot of companies out there from a market position that they really do want to reduce their carbon footprint. In ABB, we have direct targets within our own organisation, and we've made commitments to the investment community, into the stakeholders within the market, that we want to reach a net zero point by 2050. We've already reduced our own carbon footprint by 80% since 2019 to 2025. And obviously it gets harder and harder as you go through that process, but there's economic value to companies to get towards a carbon zero standpoint. From an investor standpoint, investing in companies that are driving to net zero, there are significant benefits. And naturally, there are obviously the greater community benefits of people wanting to work with these companies and buy from these companies and invest and support these companies. So there's a real desire for companies to get there. They have to generate profits in order to invest back in to reach these targets. But there are real economic reasons for companies to do this and boards wanting to do this in their own operations, as we do within ABB.
Why do you think industry has been such a laggard in moving away from fossil fuels to date?
The main thing to date is that the fossil fuels have been an easy source of power and generation. It's been relatively cheap for them to do that. And there were certain hurdles over greener powers of the availability of the power when people needed it and wanted it. So the technology hadn't really got to a stage to drive true economic benefit by going to renewables. And then as different carbon credits and other things came on board, it became more viable. And newer technologies like battery energy storage came on board. Efficiencies in wind turbines continue to improve. Distributed solar and solar efficiency became much higher. And the costs of fossil fuels continues to rise, or access to the technology around that energy source is being constrained. So I think that time of shift is now. And I think that the technology is where it needs to be, and the available offerings to the market are where it needs to be to make a reasonable and a good return on investment by going towards carbon neutrality.
And I think one of the factors has to be the price of fossil fuels being so volatile. That can't be helping, because if you can't predict what you're going to be spending on energy in a month's time, 3 months' time, 6 months' time, a year's time, it's very hard to budget. I mean, we saw that in 2022 when Russia invaded Ukraine and the gas prices spiked. We saw massive impacts for businesses. So do you think that's part of why companies are now prioritizing more shift to renewables, where if you have your own on-site renewable generation, for example, you have a very predictable, stable price?
Yeah, I think there's that predictability, but there's also the general grid itself and grid pricing and performance. In the industrial market, unlike the residential market, you have a fixed tariff rate on your electricity. In an industrial market, you have a real dynamic utility tariff rate that's going up and down. And given the security of power and the changing economic environment, that we're seeing huge swings in climate, we're seeing huge swings in catastrophic disasters, availability of power across borders between countries. Electricity prices are swinging quite wildly to these industrial players. And in some cases during the day, electricity prices can surge and cost the business anywhere up to $1 million in that one day with a surge in power. So it's not just baseline prices, It's the volatility of the utility market, the volatility on demand, and the growing demand on the energy transformation to be more electric, that the demand on power by things like data centers, high energy use type applications are straining grid capacities and then causing the surge in prices, whether it's renewables or fossil-based fuels, the unpredictability of power. So I think industrial companies are taking it on their own board to make these changes, make these investments, stabilize their own power and drive security on their own power source. So whilst they do go for solar on their domestic presence, again, you've got unreliability potentially that the solar is there when you need it. So then they're looking to battery energy storage to augment that solar, and they can install that and put that on their own site and take control of that. But they can also then trade power back to the grid and make money out of it at the same time. So they can take advantage of that volatility. They can take advantage of their own production and create a revenue cash generation for them out of trading on the grid whilst driving security on their own facility and their own site and prioritizing their own operations. So yes, I think it is because of the volatility in the price, but I think it's not just because of the fossil fuels. I think it's just the overall energy transformation demand of power and the volatility of the electricity market in general.
And what about the likes of aging electrical infrastructure? What kind of role do you think that plays in holding back decarbonisation? I mean, I remember reading a stat out of the US, and this was 10 years ago, saying that the average age of a transformer in the US at the time was 50 years, and that those transformers had been engineered to last 30 years, typically. So, and I'm not sure the situation has improved a lot in the meantime. You know, what do you think the role of aging infrastructure is playing?
Yeah, look, just to put a spin on it, we look after 17 million sites around the world today of infrastructure as the ABB Electrification service team. We got 5,000 engineers on site every day working on existing infrastructure. The current investment by utilities to reach the carbon targets that they need to reach by 2050 and the energy supply and the energy transition, whether that's renewables, maintaining fossil fuel infrastructure, they're underinvesting at a factor of 2 right now. Aging infrastructure is a major problem. Another major problem is how much work they do on maintenance of aging infrastructure and the cost of failure. We've seen a huge failure in Heathrow Airport. An electrical substation, a transformer blew up in that substation. There's a lot of questions over whether the right maintenance and support was done for that infrastructure and whether it was maintained properly. We've got similar cases all over the world. At the moment, we've got a huge contract with the Belgium nuclear facilities in Dole. We've got 2 nuclear reactors that, as electrification service, we've got a 3-year contract to upgrade and improve that infrastructure to make sure that that facility extends its life for at least another 10 years. The aim is to keep that infrastructure running and performing well beyond its original planned life. Now, within electrical infrastructure, more than 50% of the electrical infrastructure, we can refurbish and upgrade and just use the copper, the steel. That doesn't need to change. What needs to change are the switching devices, the electronics, and the predictability and management of power to the current demand from the market. So we can keep 50% of their infrastructure in place. We can take all the intelligence out of it and put modern intelligence in there and modern high-speed switching devices that can allow more power through the same infrastructure and deliver the demands that are needed for the legacy as well as the new. If you look at electronics, there's not many of us that have a 10-year-old phone in our pockets today, that electronics gets updated very, very regularly. Utility infrastructure has more and more electronics in it today than it had 20 years ago. But even 20 years ago, devices were quite static and unintelligent. They basically operated. In order to do the switching we need today of the different types of power sources, renewables, on-site demand, utility demand, we need digital to be driven into the market. And we can upgrade that aging infrastructure with the minimum carbon footprint without having to replace the steels and the coppers and reproducing that in a steel plant or out of a copper mine. We can reuse all that material and extend the life of the asset a lot longer, offset carbon in the future, but then also drive more power that is needed for the market. And I would say, Tom, about 30% of our business is what we do today, whether that's up with Vattenfall in Sweden, whether that's over with the big US utilities. About 30% of our work today is extending the life and modernising existing electrical infrastructure, which has been underinvested in for the last 50 years.
And just from a practical perspective, Stuart, what kind of impact can that upgrading and modernising existing assets have?
Yeah, so you can actually reduce the cost, firstly, by about 50%. So you're not reinvesting in that. You can also do it in a staged approach. So you can stage the upgrade and the investment. So you're not shutting things down for weeks and pulling all that electrical equipment out and then replacing it all. So you can maintain power to the site for the customer or the utility and upgrade it. Then the extension of life can be 20, 30 years extension of life. So you can give that infrastructure another 30 years. So whilst the utilities at about a half of their investment, they need to keep their existing infrastructure up and running, as well as invest in new infrastructure. So they've halved their investment, they've extended their life by about 30 years, and they've also driven minimal disruption in modernising to their customers in a staged effect. We were doing that a lot. A couple of years ago, there was a huge shortage of chip manufacturing around the world. TSMC, Intel, all were being huge demand for chips. And many of these facilities have to have much larger machinery on the shop floor than what they had in the past. So we could keep the chip lines running. We could improve the safety in the equipment with newer technology. We could extend the life of the plant by another 20 or 30 years. And at the same time, they could then increase the chip production lines and upgrade all the robotics and the fabrication lines on the production floor for their chip assembly. So this is across all industries. Data centers, they'll upgrade every 10 years. Utilities will upgrade every 30 years. Everybody now wants to recycle the products also when we do this upgrade. So when you take the old equipment out, they'll want you to recycle whatever you're taking out. They want a full circularity on that, and then the new technology going in with a recycling plan when that new product goes into their site as well.
So if we're moving into more circular models, does that mean that we're starting to shift away from CapEx investment into OpEx investment? I mean, is it going more towards the as a service model as we're seeing in most other industries?
Yeah, we're seeing a huge demand, particularly when it comes to customers trying to drive to carbon neutrality at their sites. They're trying to retrofit in onboarding solar domestically in their facility. They're also trying to bring in things like battery energy storage to complement that solar installation. As I mentioned before, trading power back to the grid, etc. But these batteries are a huge capital upfront cost to put in. And many people complain about the short-term economic benefit of batteries going into their site. There's two things that are driving it. The first one is around artificial intelligence. The way that you can predict the power and the energy usage and you meter that power from the site, you can then use the battery energy storage system to optimize the amount of charging and discharging that you're doing based on analytical data on the grid. And you can maximize the benefit of the battery and the operation of the battery at the site compared to the grid and the site's usage. So that's one economic driver. The other one is around the as a service model. We, as an example, will offer the customer a monthly subscription fee for the battery. We will provide the battery to the customer, size for what they need. We will provide the service on that battery and maintain it for anywhere up to 20 years. And that will include refurbishment, recycling, upgrade of the battery cells over that 20-year period. We'll also provide insurance, because if the battery, for unknown reasons, has failed or not performed to what it needed, we can give guarantees to the customer of the economic loss potentially of the battery. And then at the same time, we can also then offer the trading of the power and the electricity and the optimization of the energy management for the battery. The customer pays a subscription fee. It's an operational type expenditure kind of cost instead of millions of dollars of capital expenditure. It's a shared economic benefit for them putting it into site with our technical expertise. It's sitting behind the meter, so they're fully in charge of their power at their site and the resilience at their site. They're driving towards net zero because they're either producing green power or they're buying green electricity and storing that and using it when they need it and applying it rather than buying off the grid. And then they're trading back to the grid when it economically makes sense and they can afford that extra power to go back to the grid. So these as a service models open up new revenue streams to the customer, minimal upfront investment, and a vehicle for them to go to carbon neutrality, which is in an operating expenditure model without large capital outlay. And many of these industrial customers have got these economic targets, they've got cash targets they've got to deliver. So a softer approach and probably a staggered approach to entering carbon neutrality in this way is a smaller barrier to entry and easier for them. And then they can rely on expertise like we have to support them and the network that we have and experience that we've done in our own facilities and apply it to their own.
Okay. It strikes me, and I'm going to take a very simple analogy. I mean, you mentioned vehicle a second ago. If I look at the world of EVs, the price of EVs is coming down year on year on year as battery technology improves, batteries become more energy dense, and the price falls year on year on year. Typically 15% roughly year on year, the battery prices are falling.
Yeah.
So the idea of buying an EV isn't all that attractive when you have an option of maybe leasing an EV, because if the prices keep on falling, if you buy it and the prices are going down 10-15% per year, plus it becomes secondhand, you lose a huge amount of your investment in that purchase. Whereas leasing, you take away that risk.
Yeah.
And it strikes me that's the same thing, because it's the same technology, it's batteries. Yeah. So obviously, if you're a utility or whatever, or an industry, it makes more sense economically to do the as a service model rather than lashing out a huge amount of money on batteries, which are falling in their value as they become cheaper to buy upfront year on year on year on year on year. Is that a fair assessment as well?
Yeah, I think that'd be a fair way of also looking at it pragmatically, Tom, that, yeah, and also batteries do have a limited life as well. And so you do want to economically change the batteries out over time. And that's one of the reasons that EV vehicles are also depreciating so quickly, is not only the cost of the batteries coming down, but you're also using up the life of that battery on that asset of that vehicle. One thing that should be also noted is that the recovery of the battery and the recycling of the battery can actually go from vehicles in the battery energy storage, because the way we cycle a battery energy storage unit versus the vehicle is completely different. So we can take legacy batteries and recycle them into battery energy storage units, and use them in industrial applications where you can't necessarily just keep using them in motor vehicles going forward. But you're absolutely right that a lot of this is unknown. If people want to get to a net zero, economically, maybe it doesn't make sense. Do you go to the big capital expenditure and the big ribbon cutting ceremony and open up huge battery energy storage modules and solar panels and stuff for your site? Or do you go for a more risk averse approach? You've got an as a service model, you're leasing the batteries, you're putting them on your site, someone else is taking care of them, they're wearing that cost, they're helping you trade with it, and they're helping you manage that asset, and then you don't have to worry about it, right? And then 20 years later, they may have swapped it out 2 or 3 times with the latest technology, kept your site green. The footprint's obviously getting smaller over time, so you'll have more capacity and less square foot. But that's usually not the problem for the industrial site. The problem for them is how much do I need, when do I need it, and how do I need the power? And that's all taken care of in the as a service model. So it's a simple way of transacting and moving into that space.
Okay, and just how recyclable are the batteries?
Yeah, we've been working with quite a few manufacturers, and we can recover 70 to 80% of the battery and recycle that in the next generation for sure. So they're not 100%, but we can do 70 to 80% of the batteries, and we work with suppliers around the world to do that today. For all of our products, we have EPDs, documentation for all of the ABB products that not only gives you what the carbon footprint is for that product going into your site, but it also gives you the circularity of that product. So when you're buying the product, you know that it has that circularity. And then we also have what we call eco solutions products, which are independently audited, and then people can scan a code and they can get exactly that recyclability and that 100% recycling that can be achieved. But at a battery level, we can do 70 to 80% today.
And in terms of the company's desire to go net zero versus, for example, regulation forcing industry's hands, where do you see that balance coming out? And does it maybe it's something that's dependent on the industry itself? Maybe some industries are more forward-looking in this than others, maybe not. How do you see that playing out in terms of regulation versus desire to be net zero versus the economics of it?
Yeah, I think there were some large pushes that moved industry in that direction, and I think the momentum is extremely strong. I don't think it's regulation as much these days as it was driving companies. The large multinationals that we work with, particularly in areas like the data center spaces, the electronic spaces, even the oil and gas companies today have got a net zero strategy, and they're pushing those envelopes. Now, moving that net zero space as you get further along gets harder and harder and harder. So a lot of people are moving on that first 50% reduction relatively easy, but the big multinationals know that reaching these targets is not going to be easy, but their desire to get there is strong, and they see economic and competitive differentiation by achieving that net zero. So large utilities like Enedis in France are pushing SF6 gases out of their network today and driving us extremely hard to come up with vacuum technologies or new technologies implemented and retrofitted into their system at a rate at which only we can produce at. They'll take it quicker if we can produce faster. We see most of the hyperscale data centers. These people, unlike utilities, they're upgrading at a rate of every 10 years, right? In their, not 50 years, but 10 years or less. They're pushing us to complete circularity today. It's not a political decision. It's a business decision, and these companies are driving it extremely hard. Mining sites, I mentioned ABB's process automation. Electrification of mine sites regenerating power, off-highway vehicle mining trucks. We've got a whole division that works around this kind of space. The rate at which we're being approached to carbon neutral mines is incredible around the world. So Tom, I don't see it as regulation anymore. I think there's enough geopolitical challenges going on, but I think big industrial firms understand the economic benefit. Their stakeholders are wanting them to get to net zero, and everyone wants to have a good social position. And we all have to remember that from a carbon neutrality standpoint, there's a much bigger play here for all of humankind. And big companies want to be there driving that, whether it's utilities, whether it's data centers, whether it's mines, whether it's buildings. And people want to live and work in economic clean places. I'd also highlight one other thing, Tom, that we've found extremely important. If you want to hire good young talent into your businesses today, one of the strongest mechanisms that we have is our sustainability initiatives. I would say every young graduate coming out of school today, one of their first questions are, what's your sustainability objectives? Do you drive EVs in your company? How can I get involved in this? So even from a recruitment standpoint, it's being pushed on companies that if you want good young talent, you have to be a leader in this particular space. So 100%, it's companies driving it more these days. There are some economical or government incentives out there, but I'd say it's being driven more by industry. And I think when that happens, it's got a lot stronger and longer runway to perform than when it is just purely by regulation.
And for the leaders in the space who are getting it right, what kind of lessons can we take from them?
Yeah, look, I think for the leaders in the space, no matter how big or small your organization is, there's something that you can do to drive your existing infrastructure to make it last longer. Even just by doing regular maintenance on something versus it failing and then fixing it, economically, that can save you 10 times over the lifetime of that asset by doing regular maintenance. So you can do simple things like that. There are low hurdle rates to go to carbon neutrality by using as-a-service models. So, for example, if you have invested in solar and you want to maximize the use of that, you can go to battery energy storage. If you've got poor grid supply, we can then add capacitors to that and give you grid resilience as well as battery energy storage. So there's a smorgasbord of offerings out there that you can invest in as little or as much as you want. And we can start you and help you go down that journey of resilience, affordability, and ultimately sustainability in your operations. And we're dealing with people at all different levels in organizations, from a factory owner to the C-suite. So I think, Tom, it's just, there's a whole range of offerings. There's no excuse not to move forward based on the budget that you have. We can help you get to an economic stage and an economic payback pretty quickly. And we can help you become a net zero target achiever, make that part of your plan and make you a much more attractive business compared to your peers and to the younger generation.
And what excites you most about the future of electrification and industrial decarbonisation? And the flip side, what keeps you up at night when you're thinking about this transition?
The technology is moving so quickly. We can get more out of what we have today tomorrow. And applying that technology, especially in digital areas, we can move very quickly in the decarbonisation space. The transformation, the energy transformation that we're going through to electricity is very real. It is a huge opportunity for companies to make some very good, sound decisions going forward on resilience, as well as carbon neutrality. What keeps me up at night is that people aren't acting fast enough, for sure, that people are underestimating that you can just do it tomorrow. You need to start today to do it. There's a limited capacity out there. And I really think the opportunity is for distributed power, distributed networks, and generation even at the local level. But people are waiting for someone else to do stuff too much. And it's up to each of us to do it. I mean, I've done it personally on my own home. I drive an EV. The technology is moving so quick that these things are going to be extremely powerful in the future. And those that move first will be the most successful. So it's the lack of investment. They're kicking cans down the road. People are distracted by all these other economic issues that are going on. And I think people have to just keep this as a core foundation focus within their operations and their businesses. As we've seen, even Heathrow can be taken out in a day. And it's not until things go wrong that people really start to panic. And things like, the gas pipeline being shut in Europe, big investments like the Energy Act in the US a few years ago really started to move things along. I think companies need to keep moving forward and taking action. So underinvestment is my biggest headache.
A left field question, Stuart. If you could have any person or character, alive or dead, real or fictional, as a spokesperson for industrial decarbonisation or an evangelist for industrial decarbonisation, who would it be and why?
Who would it be? I think there were some great inventors in the past. Some of the people like Tesla himself. I mean, what he was doing with electricity and some of his models were fantastic, right? But I don't think people fully understood things and what the offerings were that he was working on. But I also think in the nuclear space, I think that there were too many evangelists out there for the wrong reasons around nuclear energy and what the options were. I think there's been huge progress in this space as well, driving towards carbon neutrality. And I think some of the political positions and the scare tactics and that around nuclear more as weaponry rather than an energy source were perhaps misrepresented. So I think probably they'd be two people, someone in the nuclear space and someone in the electrical generation space could have had much bigger influence than what they did through history. Whereas a lot of the fossil fuel power got up very, very fast and took over without really understanding the impact on the greater environment. But we're still learning that today. So yeah, it'd be interesting to see if that part of history changed a little bit.
Okay. We're coming towards the end of the podcast now, Stuart. Is there any question I haven't asked that you wish I had, or any aspect of this we haven't touched on that you think it's important for people to be aware of?
No, look, I think, Tom, you covered most of it. I think the energy transition is real. I think carbon neutrality is something we all should be striving to. I think as the service models, whether it's offsetting carbon or whether it's addressing carbon that we have today, either through retrofitting, upgrading and improving existing infrastructure or driving efficiencies and renewable resources in your current purchasing can easily be addressed. I think technology is moving forward in the right spaces now. We just need to adopt it and apply it. And some of these new business models out there can help us apply it even sooner and faster, even with the economic constraints that people currently have. And probably the last thing is that we can all make a step ourselves in our own businesses and our own lives to make a difference, and every bit counts.
Stuart, if people would like to know more about yourself or any of the things we discussed in the podcast today, where would you have me direct them?
Yeah, I think if they go to avb.com and learn more about the company and what we're doing, you'll find myself and my peers there talking about how we're engineering to outrun existing performances of businesses. That would be the place for people to go. But yeah, more than happy to receive any kind of requests from people via yourself, Tom, or through the website. I think that would be the easiest way for people to get in touch.
Superb. Okay. Stuart, that's been fascinating. Thanks a million for coming on the podcast today.
Been really good, Tom. Thank you for having me. I've really enjoyed it.